This is section 4.3 at the top of page 17. The example says find the local maximums and minimum values, the intervals of increasing and decreasing, the intervals of concavity, and inflection points of our function. And I rewrote the function with an exponent rather than with a root. And the first thing is, what is the domain of our function? And to figure out the domain of our function, since this is a positive root, I know that the radicand, the part that's inside, which is 4 minus x, has to be greater than or equal to 0. And then if you guys were to solve this, you would get x has to be less than or equal to 4. So it's going from negative infinity until 4, the bracket. So in order to find intervals of increasing and decreasing, your local maximums and minimums, I need the first derivative. And in order to find the intervals of concavity and our inflection points, we're going to be looking at a second derivative. And we're going to start this example together and then in the video and then finish it together in our lessons. So first thing is we need to find our first derivative. So f prime of x. And since we are multiplying two things together that have variables, we're going to use the product rule, and also we're going to be using the chain rule. So the first times the derivative of the second. And since that has an inside function also, we need to multiply by the derivative of the inside, plus the second, times the derivative of the first, which is just 1. So from here, we're going to clean this up. I am going to factor out a 1/2. And I'm also going to factor out, since these are the same, and the reason why I factored out the 1/2 is because it's a fraction, and it makes it cleaner to do that. The smaller exponent is to the negative 1/2. And then left over, so really quick, since I factored out the 1/2, that's almost like this is getting multiplied by 2. And we'll check it once we go through. But from here, I factored out the 1/2, and I factored out the 4 minus x to the negative 1/2. So I'm left over with a negative 1 times x, or negative x, plus I have that 2 here, and I factored out a negative 1/2, so left over I would have 4 minus x to the first power. And if you stop here and just pause it and just distribute that back in and check to feel better about that. I know we're starting to get used to a new idea with cleaning these up like this. But from here, the part in the brackets is going to simplify. And that's going to be negative if you distribute your 2. We're going to have negative 3x plus 8. And it's all over, there's a 2 in the denominator and a square root of 4 minus x. So rewriting this. So in order to find my intervals of increasing and decreasing in my local mins and maxes, I need to figure out the critical values that we would have. And that is going to be where our derivative is equal to 0. And also where our derivative is undefined. So if you were to solve this, this is going to equal 0 when you have negative 3x plus 8 would be 0. Subtracting 8 and dividing by 3, we get x is equal to 8 over 3. As a mixed number, this would be written as 2 2/3. And then we also know that the derivative is undefined when the denominator is equal to 0. So when we have 2 times the square root of 4 minus x equals 0. So dividing both sides by 2, you get 0. Squaring both sides, it would be 0. So working this out, you should get x is equal to 4. So from here, we're going to set up our number line. And breaking this into intervals. And again, really quick, our interval or our number line is not all real numbers. Our domain was saying that it goes from negative infinity until 4. So keep that in mind. So if you want, you can say, this goes on forever this way, but we will start this at 4. Okay, so we have 2 2/3 is a critical value, 8/3. I'm going to rewrite it as 2 2/3 just so it makes it a little bit easier to see. So we have 2 2/3. And from here, and we'll work on this together, we need to figure out a test value that's within each of these intervals and substitute that test value into the derivative to see if it's positive or negative, and that's going to tell us the intervals of increasing and decreasing. Once we have that, we can figure out if we have a local maximum or a local minimum at the values. So we will finish this up. Next thing, though, to get started with you guys is I'm going to split this page in half. And we need to be looking at for the intervals of concavity. So in order to find the intervals of concavity and our inflection points, we need to take a second derivative. So I have my first derivative on the left side of negative 3x plus 8 over 2 times the square root of 4 minus x. I'm going to use that and take my derivative of that. So my second derivative, f double prime of x, is going to be the bottom, the denominator, which was 2 times the square root of 4 minus x, times the derivative of the numerator, and the derivative of negative 3x plus 8 is just negative 3, plus the numerator, which was negative 3x, plus 8, and I'm sorry, change that from a plus to a minus, because we are using the quotient rule, times the derivative of our second function, which is going to be 2 times 1/2, and then 4 minus x to the negative 1/2, and then times negative 1. And since I multiplied by that negative 1, I'm just going to move it out in the front and make that be a plus. Okay, so that got changed to being a plus because of multiplying by the chain rule and multiplying by the derivative of 4 minus x, which is negative 1. And I'm out of room to put it over there on the right. So all over the denominator, which is 2 square root of 4 minus x squared. So from here, we're going to clean this up. And the denominator is going to simplify to being 4 over 4 minus x. And then our numerator we can factor some things out. And let's look and see, there's both of these in here. The 2 and the 1/2 would also cancel. We have a square root and then also a negative 1/2 instead of a positive 1/2. So we're going to factor out the smaller ones. I'm going to factor out 4 minus x to the negative 1/2 power. And then let's see what we're left over with. So bracket. So in the first one, we're left over with 2 times negative 3. So negative 6 plus, and that was the positive exponent of 1/2. So we are actually left over with a 4 minus x to the positive 1. And again, you do not need to put that positive 1 there, but feel free to. And then we have plus, and then we factored out the negative 1, the 2's reduced, so I'm left over with negative 3x plus 8. So in here, we're able to simplify this. So we end up with negative 24 plus 6x, and then we have minus 3x plus 8. So cleaning that up, we have 4 minus x to the negative 1/2 times, and then this is going to simplify to, we have 6x minus 3x, which would be 3x, then negative 24 plus 8, which is negative 16, all over 4 times 4 minus x. So still cleaning this up, the negative exponent means that that needs to move to the denominator. And if you notice, you already have a 4 minus x to the first down here. So if you move the 1/2 down there, you're going to have 1.5 or 3 over 2. So rewriting this, at 3x minus 16 over, and then 4 times, and I'm going to write it as the square root of 4 minus x to the third. So in order to find our possible inflection points, we take our second derivative and we're going to set that equal to 0, and then also look at where this is, could be, the second derivative is undefined. So setting this equal to 0 and solving this, we're going to end up with 3x minus 16 equals 0. And then solving that, you're going to get x is equal to 16 over 3, which is going to be the same thing as 5 and 1/3 as a mixed number. And then we also have to look at where this function is undefined. And the second derivative is undefined. So second derivative is undefined. When the denominator is equal to 0. And when you go ahead and you solve that all out, you should get x is equal to 4. So again, we're going to make another number line, and our number line is going from negative infinity to 4. So if you notice, we have a little bit of an issue with our first possible inflection point. So this was a possible inflection point. And the issue is that 5 and 1/3 is not in our domain. So we don't even have anything right here to worry about. So the only possible inflection point is at 4, which is at the end of our domain. So pretty much this concavity of our whole interval is going to be the same. So the whole graph is either going to be concave up or the whole graph is going to be concave down. So, and again, we need to pick a value in here to test, something smaller than 4, and substitute that into our second derivative to figure out if it's concave up or concave down. And so again, this is a problem that we just are starting right now in the video, just to kind of get through the derivative parts, and from here we'll work out the rest of it and figure out the intervals of increasing, decreasing, the maximums and mins, the intervals of concavity, and if we have any inflection points. Right underneath this, so again, we'll still figure that part out together, is a summary. So this is nice to look at because there's so much going on. So take some time to read through that on your own.